Hi everybody. So this video is going to be over your 1.2 notes. At the beginning of each of the sections, you guys will see a list of different kind of questions that you should reflect on throughout the rest of this section while you're taking the notes. So if you want to, you can go ahead and read those. The notes today start with the definition of a Venn diagram. So a Venn diagram is a graph that helps compare and contrast sets. So that helps us figure out what things are similar and what things are different. Each set is represented by a circle, and the circles that have elements in common overlap. And so as long as a item in your list of things belongs to both of the circles, then your circles will overlap. The circles are going to be enclosed in a box, so that's something that is important, which represents a larger set and provides a space for elements that don't belong to either circle. So the first thing that we're going to do is we're going to look at example 0. It says to use a Venn diagram with circles representing prime numbers and even numbers. And we're going to sort through the whole numbers 1 through 8. And we're going to change those. I'm going to change this to the numbers 2 through 9 just to make it a little bit easier. Okay, so the first thing we're going to do is we're going to create our 2 circles. And we do want them to overlap because we're going to find that there are some numbers that belong to both circles. And we're going to create a box around it. Your box is super important. Don't forget to create that box around the 2 circles. All right, the next thing we want to do is label each of the circles. One of them is going to be prime numbers, and the other one is even. And to the right over here, I gave us the definition of what a prime number is. And it's a number that is only divisible by itself in 1. So for instance, the number 3, only 1 and 3 evenly go into 3. So 3 would be prime. So what I want to do over here is I want to just kind of make a list of all of the different numbers that are going to be placed in my Venn diagram. So I'm going to list the numbers 2 through 9. So the next thing that I want to do is kind of think about whether or not they are prime and also if they are even. So even before we worry about the Venn diagram, I want us to go through and kind of see which ones are prime and which ones are even. So let's start with prime. In order for it to be prime, it can only be divisible by 1 in itself. So 2. Only 2 times 1 gives us 2, so 2 is prime. 3. Only 3 times 1 can give us 3. 4 is not prime because you could do 2 times 2, so 4 is not prime. 5 is prime. Only 1 times 5 will give you 5. 6 is not because you could do 2 times 3. 7 is. 8 is not, you could do 2 times 4. And 9 is not because you could do 3 times 3. So the ones with the purple check mark are prime. The ones that are even are the ones that are divisible by 2. So multiples of 2. So 2, 4, 6, and 8. All of those are even. So what I'm going to do over here, and you don't have to do all of this for all of the problems that you have with the Venn diagram. You'll usually get the hang of it. What I'm going to do over here is kind of list the different categories. We have numbers that are prime only. We also have numbers that are even only. We have numbers that are both even and odd, or sorry, even and prime. And we also have numbers that are neither Okay, so I'm going to list the numbers that belong to each of these. So 2 is both. So 2 would fit there. 3 is only prime. 4 is only even. 5 is only prime. 6 is only even. 7 is only prime. 8 is only even. And 9 is neither. So I now have to figure out where in this Venn diagram will each of these belong. So what I'm going to do is shade this for you so you can see that there are 4 different places that you could place numbers. If you look at this one, or actually let me color it with purple so it matches that. So over here we have prime only. So our numbers 3, 5, and 7 will go there. You can just place them anywhere as long as they're in this part of the circle. You do not want to place it in the overlapped area. All right, for the even ones, those ones are going to go on this side. So for the even only, I'm going to place 4, 6, and 8. Now when we get to the middle is where they are both. So in that one, I'm going to place the number 2. And then we have the outside space. So the outside space is going to be where we have neither even nor prime. So anywhere in the orange is where you could place the 9. So just to make sure that you guys understand, we have 4 different places that we can place numbers. We have it in the prime only. We have it in prime and even. We have it in the even only, and we have it in the neither. Okay, we're going to go back to a few Venn diagram examples later. The first example that we have has to do with fractions and what this also looks like as a percent. So there are going to be other examples too that get you guys familiar with this. So in example 1, it says in a class of 20 students, 17 of the students passed a prerequisite skills quiz. What percent of the students passed the quiz? So there's more than one way to do this, but I'm just going to show you guys the most simple way. So the most simple way is to first write it as a fraction. So 17 of them did pass it out of a total of 20. So what I'm going to do is I'm going to divide so that I change my fraction into a decimal. So whenever you guys want to change a fraction into a decimal, all you have to do is divide. So in your calculator, you could just do 17 divided by 20, and you get 0.85. Okay, the next thing that I'm going to do is change it to a percent. So to change it from a decimal to a percent, you're just going to multiply by 100. You can also think of it as moving the decimal place 2 places to the right. Either way, so take that times 100, you get 85, and stick a percent symbol on it. And that's it. Okay, the next page is kind of a reference page for you guys. For fractions and how to use them. One other thing I want to point out while we are doing this video is if you look at the top of your pages, I've got notes, 1.2 notes on the pages that are going to be for your note videos, and I have the page numbers along the bottom so you can kind of watch as we go along. When we are done with the notes section, you guys will see that they start being labeled as 1.2 practice. So like on page number 9, you see that instead of saying 1.2 notes, it says 1.2 practice. So this is something that is optional for you guys to do. If you want to have extra practice other than the homework problems, you can do these pages, and the answer keys will be posted as either a PDF, so a file that you can just check your answers with, or they will be posted as a video explaining the answers throughout the video. And that will be posted in your course materials on Blackboard for you. All right, so let's go ahead and continue with the notes on the top of page 3. So page 2, I included in there for everyone so that you could see the steps. And you can see even here, it does explain how to change it from a decimal to a percent. So you have that in reference as well. And don't worry about number 6 at the bottom. So just use this top part to help you understand how to do things with fractions. All right, so example 2 says, suppose at a college 1/3 of the freshmen start in the beginning algebra and 1/5 of the freshmen start in intermediate algebra. What fraction of the freshman class start in one of these two developmental classes? And then it says, to the nearest whole percent, what percent of the freshman class does this represent? So to find the answer, we need to add the fraction of freshmen who start in the beginning algebra to the fraction of freshmen who start in intermediate. So we're taking and combining these two fractions. But if we were to just take 1/3 plus 1/5, I'm going to show you guys why that is not just going to equal 2/8. So this is an important concept for you guys to understand, that you can't just add the tops and the bottoms together. The biggest reason why is the bottom represents how many pieces make up a whole. So let's say that we have a pizza and it is cut into thirds. I'm going to just do my best to kind of show you a pizza that's equally cut into thirds versus a pizza that is cut into fifths. You can see that the sizes of the the sizes of the pieces in this one are smaller than the sizes over here. So we can't just add them together because they don't represent the same portion. Also, what you can do is you can change these to a decimal. So if you took 1 divided by 3 in your calculator, you would get 0.3 repeating. I'll just use 4 decimal places for now. If you take 1 divided by 5 in your calculator, you get 0.2. And if you want to write the 0 in front, you can. It's optional though, you don't need to. And we want to see, does that equal 2 divided by 8? So if you take 2 divided by 8 in your calculator, it is 0.25. So add those up together, you get 0.53 repeating. That does not equal 0.25. So we can see that this is not going to work. So the biggest solution that we have here is coming up. So since thirds and fifths are different sized pieces of a whole, We can't add these fractions as they are. We can, however, change each of the individual fractions into an equivalent fraction with the same denominator. And in this case, it's going to be 15. So what I'm going to show you guys is how we can create equivalent fractions. So a fraction is equivalent if it can be simplified into the original form. So, or one of the other forms. So if we multiply the top and the bottom of a fraction by the same number, you will get an equivalent fraction. So, and you can also do it with dividing. If you have a fraction that can be simplified, let's say that we have 4 over 8, you can create an equivalent fraction by dividing the top and bottom by the same number. So if we divided the top by 4, we would get 1. Divide the bottom by 4, you would get 2. All right, so what they said though is we want to change each of the individual fractions so that we can add them by creating the denominator as 15. So I want the new denominator, or the bottom of the fraction, to be 15. So I'm going to take and find what will multiply with the original denominator, so I get 15. So in this first one, 3 times 5. And remember, if I do something to the bottom, I have to do it to the top so that it's an equivalent fraction. So I get 5 over 15. For your bottom one, you have to think 5 times what will give me 15, and that would be 3. So 1 times 3 is 3. Now we have fractions that have the same denominator. So now I can add these together. So in order to add them together, you leave the denominator the same and you just add the numerators. So we get 8 over 15. And that cannot simplify because there's not a number that goes into both 8 and 15. Okay, I am also going to talk to you guys about how these can be done in your calculator as well. If you have a scientific calculator, and all of the calculators that I listed at on your syllabus, those have a fraction button. A lot of times the fraction button will look like A and then B over C, or sometimes it just has blank spaces on the top and the bottom, or it has N over D. All of those are your fraction buttons. So each of your calculators should have one of those different buttons to help you. I'm going to post a video in your course materials on Blackboard. So check your course materials for a video on fractions with your calculator, because you are allowed to use your calculator. So if you want to just use your calculator to do these problems, fine by me. It's actually a great way for you to use the technology resource and not have to worry about the math. That's not always going to be the case in a class like this, but hey, your first section, you get to use a calculator to do the math. All right, so let me show you how we would do 1/3 plus 1/5. So I'm going to go ahead and even just write that over here so we still have it. 1/3 plus 1/5. What you're going to do is you're going to use the fraction button on your calculator. On this one, it just looks like this. And I am going to first type in the 1 for the top. For the bottom, I'm going to type in the 3. Okay, what we're going to do next is we're going to add 1 over 5. So I'm going to type the fraction button in again. I'm going to have 1 over 5. And then I can press equals, and it will add those for me. And if you look at this, it matches what we had on the beginning of the problem when we changed it to a decimal with 0.53 repeating. Okay, looking at example 3. This one says in a particular college, half of all freshmen start in developmental math. Of those who start at this level, 4/5 start in beginning algebra. What is the chance that a freshman at this college starts in beginning algebra? So you're looking for 4/5 of 1/2. And don't get freaked out that you can't find another number here because they just write it in words. So they're just saying half. So we know that 4/5 of half the freshmen are taking this beginning algebra. So whenever you see the word of, that's a clue for you to multiply. So of in math means to multiply. So what you're going to do is take 4 over 5 times 1 over 2. If we were to do this using our math methods, you're just going to multiply the numerators and multiply the denominators. So for the top, 4 times 1 is 4. The bottom, 5 times 2 is 10. This one can be simplified. It is the same as 2 over 5. And we would divide by 2. Sorry, I forgot to write the 2. So there is a 2 in 5 chance that a freshman at this college would start in beginning algebra. Okay. If you wanted to do this one in the calculator, 4 over 5 times 1 over 2. So using a calculator, I would press my fraction button when I went to go input the, whoops, it still has it set on that one. All right, so I'm going to use 1. So I've got the problem right up here for you guys. I'm going to use the fraction button, and I'm going to type in 4 over 5. And then I'm going to multiply it with, so I'm going to arrow out of that. And then I'm going to multiply it with, so times, and I'm going to use 1. So type the fraction button, 1, and then for the bottom, it would be 2. And you get 0.4, which is the same as 2/5. In your calculator, you should get your answer as a fraction still. Okay, so looking at equivalent fractions. So always check to see if a fraction can be simplified before you write the final answer. Something really nice about your calculator is if you just type in the fraction, so if I wanted to type in the fraction 4 over 10 into my calculator, I can just enter it in the calculator and then it will automatically simplify it for me. So I don't even have to put in an operation. I can just type in the calculator 4 over 5 and it'll simplify it to 2 over 5. Okay, so that's something that's important. On your MyMathLab homework, it's going to probably happen to you guys that you type in an answer that is not simplified, and it won't mark it correct until you have it simplified. So just check with that. Okay, So an equivalent fraction can be written with a different denominator by multiplying or dividing both the numerator and denominator by the same non-zero number. So 2/3, that is as simplified as it will get because there isn't a number that goes into both 2 and 3. But what I can do is I can multiply it by another number on the top and the bottom so that I get a larger number. So let's multiply it by 2 on the top and bottom. That would give us 4/6. So 4/6 is an equivalent fraction with 2/3. Another one that we could do is 12. So let's say I want to take and multiply the top and the bottom by 12. If I do that, I get 24/36. This problem only asks us to write 2 equivalent fractions, but let's go ahead and do one more. So 2/3, you could multiply by 100. So 200/300 would work. All right, example B is 24/36. And if you look, 24/36 is one of the answers that we got. So if we took 2/3 and multiplied it by 12 on the top and bottom, we could go back to 2/3 by doing the opposite. We could divide by 12 on the top and the bottom. So 24 divided by 12 is 2. And 36 divided by 12 is 3. So we ended up back with the same one. All right, let's do one more. Let's think of a number that goes into both 24 and 36. Let's go ahead and do 2 because it's even. So 24 divided by 2 is 12, and 36 divided by 2 is 18. So all of these are equivalent fractions. To add fractions with the same denominator, it's fairly simple. You are just going to add the numerators and you keep the denominator the same. So, example C, the denominators match. So our answer is going to still be over 8, and we're just going to add the 3 and the 2, and that gives us 5. Remember again, if you wanted to, you could also type this in the calculator. I also know that this is my final answer because it can't be simplified. 5/8 doesn't have any numbers that go into both 5 and 8. Example D. The denominators match, so I am going to add the numerators. So if I add 3 and 2, I get 5 and keep the denominator as 10. Now 5/10 can be simplified because both of the numbers 5 and 10 have 5 go into it evenly. So if I take and divide out 5 from the top and the bottom, I would get 1/2. Again, this can be done on the calculator, and if you just added 3/10 plus 2/10 in the calculator, you will end up just getting a final answer. They won't even have you use the middle step here. You'll just get a final answer of 1/2. Okay, to add fractions with different denominators. These ones can also be done in your calculator. So if you're getting comfortable with using your calculator and you want to just kind of fast forward in the video until we get to multiplying with fractions, that is okay. Don't worry. All right, so we want to think of what can we change the bottom of the fractions to so that they match. So what we're looking for, our goal is to find the smallest number that both 8 and 12 go into. So if I think of the multiples of 8, the multiples of 8 are 8, 16, 24, 32. If I think of the multiples of 12, 12, 24, and I can stop there because I've got a match. So 24 is something that I can have the new denominator be. So that is going to be my new denominator. So I want to think, what can I multiply the current one by so that I get 24? So if I multiply it by 3, that would work. So do the same to the top. 5 times 3 is 15. Now we're going to look at the bottom. We're going to think 12 times what is 24? And times 2. So do the same to the top. Okay, now we can add these, and if we add those together, the top is 17 and the bottom stays 24. And if you subtract, it is going to be the same exact steps here. So there's no difference. The only difference is in the very last step, instead of adding the 15 and 2, you would have subtracted. All right, let's look at example N. With this one, we want to think, what number do both 5 and 10 go into? Well, actually 10. So I'm going to rewrite these so that they change to having a bottom over 10. And if one of them doesn't change, so the top, the first fraction is already over 10, I don't have to do anything to it. I can just rewrite it. Now this one we do need to change, so I want to think 5 times what will give me 10, and that would be times 2. So 2 times 2 is 4. Okay, now that the bottoms match, they're both 10, now you can just have it over 10 and add the top numbers. So you get 7. So 7 over 10. And that is my final answer. If I were to check in my calculator if that can be simplified, it can't. Just as a refresher, just as a reminder for you guys, remember that page 2 here in your packet goes over how to do all of the operations. So if you need a quick refresher, page 2 is where to find it. All right, now that we have gone through adding and subtracting, when we have the same denominator and different ones, we're going to get into multiplying and dividing. And these ones are actually a lot simpler. All right, so to multiply your fractions, you're just going to multiply the numerators together and then multiply the denominators. That's it. The only thing you need to make sure to do at the end is see if you can simplify it. Okay, so 2 over 5 times 7 over 4. So multiply those numerators and then multiply the denominators. So you get 14 over 20. Both of those are even. So if they're even, I can divide out by 2. So I get 7 over 10. For example F, same idea here. 1 over 3 times 2 over 9. Multiply the top numbers. You get 2, and the bottom is 27. That can't be simplified, so that's my final answer. Okay, we're dividing fractions. It says multiply the first fraction by the reciprocal of the second fraction. So reciprocal just means the same fraction, but you flip the numerator and the denominator. So one way to remember it is this phrase: keep, change, flip. Keep, change, and flip. So you keep the first fraction just as it is. You change your operation to multiplication, and you're able to change it to multiplication by flipping your second fraction. Now remember, you don't change the first fraction, you leave it just as it is. But the second fraction, you'll switch the numerator and the denominator. That allows you to change this to just multiplication. So now we transformed this problem into a multiplication problem, and you'll do it just like you did these other examples. So 2 times 4 is 8, 5 times 7 is 35. This can't be simplified, so that's my final answer. Okay, let's use keep, change, flip with this one. Keep the first fraction, change your symbol to multiplication, and flip this second fraction. And now you can treat this like you did the other problems. So 1 times 9 is 9, 3 times 2 is 6. This one can be simplified. 3 goes into both of them. So you get 3 over 2. Again, if you just want to do these on your calculator, that's fine. You can just type in the original problem. Okay. Looking at converting a fraction to a decimal. For these ones, really all you need to do with this is use your calculator. So I would not even worry about this first part. Just use your calculator to divide the numerator by the denominator. So you would just do 2 divided by 25. In the calculator, that gives you 0.08. And that is a decimal. Let's go ahead and also write it as a percent, just to get practice with that as well, because we're going to use that a lot in the class. So if you want to change it to a percent, just multiply by 100, or you can move the decimal 2 places to the right. So 0.08 times 100, you get 8%. For 6 divided by 7, we're going to do 6 divided by 7. We end up with 0.857. It kind of continues for a while. I'm just going to leave it like that for now. If we want to change it to a percent, we're going to multiply by 100. So we get 85.7. Let's say that the question asked us to round to the nearest whole percent. I would change that to approximately, and those little squiggly equal signs, that just means approximately. Okay. We are going to skip this connect problem. At the end of your sections, you guys will see kind of a reflection and a wrap-up of the different topics that we covered as well. So if you want to read those, you can see the different objectives that we met. Okay, the rest of your notes for this section go over some problems that are similar to what you'll see in your homework. So I may skip around a little bit, so just kind of pay attention to the page that we're on and also what problem we're working with. All right, I'm going to jump past number 7 and have us look at number 8. For number 8, it says a cookie recipe calls for 2/3 of a cup of flour to make 2 dozen cookies. So for 2 dozen cookies, you need 2/3 cup of flour. And we're going to use that for the other ones, or for the other parts. So for part A, it says, if you plan to make 8 dozen cookies, how many cups of flour would you need? So there's two ways of doing this. You can think of this as an addition problem or a multiplication problem. I think it's a little bit easier to treat it as an addition problem for you guys. So if you have 2/3 of a cup for 2 dozen cookies, and we're looking at making 8 dozen, we would need 4 sets of the 2 dozen cookies. So we would need 4 of the 2/3 cups. Now with that, all of the denominators are the same. So you're just going to have 3 on the bottom, and you can just add the numerators. So 2 plus 2 plus 2 plus 2 is 8. If you want to change this to a mixed number, you can use the second or shift button. It's either going to be second or shift at the top, and then you would press your fraction button. And that's going to change the format of the fraction from either a top-heavy or an improper fraction to a mixed number. And so if you did that, you would end up with 2 2/3 cups. For part B, how many cookies can you make if you have 10 cups of flour and want to use it all? So if you have a total of 10 cups and it's being divided into portions that are each 2/3, you're going to take 10 divided by 2/3. This 10 can be written as a fraction by just putting it over 1. So any whole number can turn into a fraction by just putting it over 1. So I'm going to rewrite that problem so that both of my numbers are fractions. And now you know from the previous page that we can change division into multiplication. So I'm going to take 10 over 1. I'm going to keep that, change this to multiplication, and flip the second fraction. Okay, now I can just use multiplication. So 30 over 2, I get 15. And I know that 2/3 of a cup of flour is for 2 dozen cookies. So if I'm looking at 15 sets of those, I'm looking at 15 of 2 dozen, which would be the same as 30 dozen cookies. Dang, it's a lot of cookies. For 9a, it says what operation is implied between the whole number and the fraction parts of the mixed number. So if we think about 4 2/3, it's 4 with 2/3, so we can assume that it's using addition. So this says, what is the procedure for converting a mixed number to an improper fraction? You guys can use your calculator, but if you wanted to, if we were to take 4 2/3, we would first multiply the whole number with the denominator. The second step would be to add that to the numerator. And the last step would be to keep the denominator the same. So I'll show us what we would do. Take 4 times 3. 4 times 3 is 12. You're going to add that to the numerator. The current numerator is 2. So we get 14. That's our new denominator, and keep the previous denominator the same. So we should get 14 over 3. Part C says to illustrate the procedure by changing 4 2/3 to an improper fraction. And so that's what we did here. What they want us to do though also for part E is to actually like illustrate it. So I'll have us even look at here and here. So don't worry. So if we were to think of it as everything is in thirds, we need 4 completely filled pieces or bars, like 4 complete wholes of thirds, and then one of them to be 2/3 full. So 4 of them are going to be completely filled because we have 4 whole parts. And then your 5th one is only going to be filled 2 out of the 3. And you can see that if we also thought about it as how many pieces are actually used up or colored in, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, and each individual whole has 3 parts to it. So that's another way for you guys to kind of think of 14 over 3. And if you were to take 14 divided by 3 in your calculator, you would get 4.66 repeating. All right, so, and that makes sense. That would match up with 4 2/3. Okay. I am going to have us skip this problem, this discover activity, and jump to page 8. And page 8 has just a little bit more Venn diagram practice. All right, so in problem number 1 on page 8, you guys are asked to use the Venn diagram to answer the following questions. Part A says, which letters are in set A but not set B? So we only want those that are in set A. So I am only going to have the ones that are in this orange area right here. I'm not going to have any that are overlapped with the B circle. So the only ones that are in set A are S, P, and X. Okay, the next one asks me which of the letters are in set B but not set A. So it wants only set B. So that would be D, R, and W. The next question says which letters are in both sets A and B. So that would be in the space that's overlapped. So that would be H, N, and V. And then the last question says which letters are in neither set A nor set B. So that would be any that are in the blue area on the outside. So that would be G and K. Just be careful, the A and B here are to label set A and set B. So G and K. I'm going to also have us answer 2 other questions. So I'm going to have us answer parts E and F with this one. So part E, I'm going to have you guys answer which letters are in set A. Now this one doesn't give any restrictions. So we want to list any of the letters that are in set A. So what you want to do is you want to make sure that you include any that are within the actual circle drawn. So that would be S, P, X, H, N, and V. For part F, we're going to answer which letters are in set B. Again, this one doesn't have any restrictions given to it. So you want to include any that are in set B. So you want to look at the entire circle. So that entire circle is going to include H, N, V, D, R, and W. The last question that we're going to be looking at on page 8 is number 2. This one we're going to be creating a Venn diagram. It says in a freshman class of 1,000 students at a particular college, 750 are taking either a developmental math or reading class first semester. So we know that there are 1,000 students. 750 are taking either math or reading. Of these 750, 477 are taking both. So they're taking both, and 172 are taking only the math. For part A, it says draw a Venn diagram to represent this situation. Use 2 circles, one for developmental math and one for developmental reading, and enclose them in a rectangle that represents the entire freshman class. So you want to make sure that you have a rectangle that represents all the freshmen. We're going to write numbers in each section to indicate how many students are in that particular category. So I'm going to have an entire box, and in the entire box, it's going to represent all 1,000 of the freshmen. I'm going to have 2 circles. One of the circles will represent those that took the developmental math, and the other will represent those that took the developmental reading. Now, something that I want us to realize here when we do this is we're going to place numbers in 3 different locations, because remember, you're going to have some students that take just the math. You're going to have some students that take just the reading, which would be this part over here. You're going to have some students that take both, and you're going to have some students that take none. So what I want us to do is I want us to figure out what we have for if we have any of the numbers that fit exactly into one of the spaces. So I'm going to go ahead and label or in color the math only section as the pink. Then I'm going to have the both of them be blue, the reading only be purple, and then I'll have the neither be green. Okay, so when I look at the fact that I've got 4 different places where I'm going to label with numbers. I want all 4 of them to end up equaling all of the students. So all 4 of them should end up equaling 1,000. So 1,000 isn't going to go into any one particular category. It's going to go into all 4 added together. So this one right here is going to be all of them added together. The next piece of information they say is 750 are taking either developmental math or reading during the first semester. So if they're taking either developmental math or reading, that's going to be all of them except for the green. So all of them except for the green are going to be taking developmental math or reading. 477 are taking both a developmental math class and a developmental reading class. Well, dang, we've actually got one of the official spots. That blue one is exactly 477. So right here in the middle, those students are taking both of them. The next piece of information says 172 are taking only a developmental math. So that tells me that just the pink is 172. So right here, I can put 172. So when I look at the one above, right here, my pink spot is going to be 172. The one for both of them, the blue, is 477, and I just need to solve for what the purple would be. So what I can do is, let's go ahead and do the work over here. I can take 172 plus 477, add those up. I get 649, and I know that these two plus the purple will add to 750. So I'm going to take 750 minus the 649. So I get 101. So the purple is 101. All right, that means that I have enough information to find the green. What you can do is you can do 2 things. I like to think of it big picture. We know that these 3 right here add up to 750. So 750 are taking a developmental class, whether it be reading, math, or both. So if we know that 750 are taking developmental class, we can take that away from 1,000 to get 250 for how many are not. And if you added up all 3 numbers, you would get 1,000. Okay, for part B, use the Venn diagram to determine how many students are taking a developmental reading class, but not a developmental math class. So this is really just saying reading only. So just looking at your Venn diagram here, we have 101 students. For part C, use the Venn diagram to determine how many students are taking neither. So that would be the outside part, 250 students. Now make sure that your outside part is in a box though, so you do want to include your box. And you also want to get in the habit of including labels with your answers. Okay, that sums up section 1.2. Don't worry, your other sections will not be as long.